Okay, so we're wanting to show under what conditions on sets A and B is the power set of A union B equal to the power set of A union the power set of B, right? We've already proven that the power set of A union the power set of B is a subset of the power set of A union B. So we are going to try to find some conditions that make this statement hold. The power set of A union B being a subset of the power set of A union the power set of B. We need to find conditions on these two sets A and B so that way this is true because this is not universally true. Okay, so because if we have this set is a subset of this set, right? And this set is a subset of this set, that means we have this right here. We have these two sets are equal, right? So we have this. So we need to find the conditions that make this hold. Okay? Okay. So let's go ahead and start. Let's see. So let's let X be an element of the power set of A union B, right? So this implies, by definition of power set, that X is a subset of, not power set, is a subset of A union B, right? So now this is the tricky part. We want to get from X's subset to A union B to maybe X is a subset of, oh, X is a subset of B perhaps, right? Because if X is a subset of B, this implies that X is an element of the power set of B. And of course, this implies that X is an element of the power set of A union the power set of B, right? So if we can get from here to here, then we're good, right? But the question is, how are we going to do that, right? So let's go ahead and draw a picture, right? Okay. So here's the universal set, and we'll have A here and B here, right? Well, we know if X is a subset of A union B, then X could be completely just in A in this part here, right? So this would not imply that X is a subset of B, right? So we can't have the picture look like this, but what we can do is we can have the picture look like this, right? Where we have B on the outside and A completely contained in B. Because regardless of where X is, right? X is still a subset of B, right? Regardless of where we put X. Because in this instance, A union B is actually equal to B, right? A union B is this piece and this piece, right? So it's that entire shaded region, which is just B, right? So one of the conditions are if A is a subset of B, then X is a subset of A union B implies that X is a subset of B because A union B is equal to B, right? And then of course, if X is a subset of B, this implies that X is an element of the power set of B, which implies that X is an element of the power set of A union the power set of B. So if we have this condition A is a subset of B, then we're able to get from X being in the power set of A union B to X being in the power set of A union the power set of B. What happens if we have B be a subset of A, right? So let's try that out. So if B is a subset of A, then, right? So let's go ahead and draw a picture again. Okay, so we have this universal set, and we'll have B this time be the subset of A. So I have this big old set be A, and the set inside be B. Well, notice regardless of where we put X, right? X, if X, right? If X is a subset of A union B, right? This will imply that X is a subset of A, right? Because A union B in this case is equal to A whenever we have B being a subset of A. And then, of course, if X is a subset of A, this implies that X is an element of the power set of A, which of course implies that X is an element of the power set of A union the power set of B. And look at what we have here. So we met the conditions. We got X is an element of the power set of A union B, 2, X is an element of the power set of A union the power set of B. So we know, thus, if A is a subset of B, or B is a subset of A, right? Then we have that the power set of A union B is a subset of the power set of A union the power set of B, right? And we already had that the power set of A union the power set of B was a subset of the power set of A union B. So if we have these two, then we know that the power set of A union B is equal to the power set of A union the power set of B, right? So this is a nice problem to sort of just go through the line of reasoning and see where it falls short, and then you can input a condition that would get to the desired result. Very nice problem in a transition to advanced mathematics textbook.